In this video we want to look at the most basic rules for finding the derivative of a very simple kinds of equation situations. If you're using James Stewart's calculus textbook, this relates to section 3.3. Now the rules that we're about to talk about in this video and the next two basically have to do with simple situations. You could plug them into the derivative formula that 3.1 discusses. That is, that a derivative is the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. You could plug these equation situations into that and come up with the same thing. But in practice, there's no reason to. There are some basic rules that if you just memorize them, and they make perfect sense, then it's very simple to find the derivative of something without going through all that technicality. The most basic of all is, of course, the derivative of a constant. The derivative of a constant, say the derivative of 4, is going to be 0. And this makes perfect sense because x equals 4, for example, is a horizontal line. If you were to graph it, it would be a flat line. What's the slope of a horizontal line? Well, a horizontal line has no slope. And therefore the derivative of any number, the slope of that, the slope of any number is going to be x equals 5, 6, whatever. The slope is going to be 0. So it makes perfect sense that the derivative of a constant is going to be 0. Also very simple is the constant multiple rule. That is, if you have a constant times a function and you want to find the derivative of a constant times a function, the derivative of a constant times a function, say the derivative of 4x, is going to be the constant times the derivative of the function. In this case, just 4. Again, this makes perfect sense. You pull the constant out. You can pull it right out. And so the derivative of a constant times a function is simply the constant times the derivative of the function. Also very easy, very nice, is the sum rule. If you're trying to find the derivative of two constants added together, the derivative of f of x plus g of x, it's simply the sum of the derivatives of each of those functions individually. So the derivative of f of x plus g of x is the derivative of f of x plus the derivative of g of x. Similarly, the difference rule is exactly the same, that if you're trying to find the derivative of one function minus another, then it's going to be the derivative of the first function minus the derivative of the second function. These are all very simple, very basic kind of, you can do them without even thinking. By far, on this video, the most important rule of all, and one that a person will use over and over and over again when doing practical applications to calculus, is the power rule. The derivative of x raised to the n power. And if you want to run it through the basic derivative formula, the limit is delta of delta x as delta x approaches 0 of f of x. If you want to run it through that, you can prove what the rule, but there's no need to. It all boils down to this. The derivative of x to a power is the power times x to whatever the power was minus 1. So x to the n power, the derivative of that is nx to the n minus 1 power. Very simple. So the derivative of, say, x to the third power is going to be 3x to the second power. The derivative of 3x to the second power is going to be 6x to the first power, or 6x. The derivative of 6x is going to be 6, because the derivative of 6x to the 1 power is going to be 6x to the 0 power, and x to the 0 power is 1. So this applies for negative, it works for negative powers, it works for fractional powers, such as x to the 1/2 power, which is a square root, or x to the negative 1 power, which is 1 over x. It works for basically all x to whatever n is. It works. This is bread and butter calculus.